Welcome. In this video I'm going to show you how you can obtain different means using Python. I'm running Jupyter Lab together with Python version 3.818. So when I talk about the mean, most people will interpret that actually as a so-called arithmetic mean, or average they would even refer to it, which is one of three Pythagoras means. Those were the ones that can be also shown as a geometry in a geometric way. The arithmetic mean is the most famous one. It's the sum of everything divided by the number of items, but it's actually also the balancing point of a distribution. It's what everybody would get if everything would be divided evenly. The harmonic mean is often used with ratios, and the geometric mean with, for example, compound interest. And because means are quickly influenced by extreme values, one way to counter that somewhat is by trimming some of the data. So simply remove some of the highest and lowest values, and then you get a trimmed or truncated or Windsor mean, it's sometimes called. Not to be confused with a Winsorized mean, which doesn't just remove them, it actually replaces them with the nearest non-removed value. I've also seen something known as an Olympic mean, which was just the maximum and the minimum got removed and then divide the rest accordingly. And I also seen decile mean, which is just the average of the 9 deciles from 10% to 90%. Last thing is actually the mid-range, which is simply the average of the maximum and the minimum. Very similar is actually mid-quartile range. That's the average of the two quartiles, the first and the third. That's actually discussed in my video on quartile ranges. To show you how you can calculate all these means, I'll load in some example data using pandas. So I can use their read CSV to load the General Social Survey 2012 adjusted for some examples. I don't need all the data, I just need one numeric field, so I'm going to be using age for that, which actually had a category 89 or older, so I'm going to replace those with 89 and remove all the missing values, and that's what's being done here. Make sure everything is numeric, and now I have a fully numeric field. In another video I show you how you can just quickly obtain all these measures with my own library and the me mean function in there. I also made another video about other libraries, and in this one I will try to avoid most of the libraries that come with Python. So the first thing I'll do is actually I need the sum of all the values. Actually I need to know how many values there are. I can just use the len function, and for the arithmetic mean it's just the sum of all the values divided by that n. The harmonic mean has this formula. It's actually 1 over each of the values. You sum everything and then n divided by that. So I can simply do that in one go. I can say, well, the sum of 1 divided by the scale field, and that should give me the required result. The geometric mean, now if, for example, this isn't a pandas series, then you can just use a quick for loop for this. The geometric mean has this scary looking formula. So if we have the exponential and the log function, so exp and log, then available in Python's math, then we can simply fill it out and get the so-called geometric mean. The mid-range is very simple, just the minimum and the maximum divided by 2. So let's quickly get that out of the way. The Olympic mean is actually all the scores minus the minimum and the maximum, and then divided by the number of scores minus 2. So that's done over here. The most tricky one is probably the trimmed one. So we're going to remove some of the data. So, and that depends on the proportion we are using. So let's say I'm going to be removing 20% from each side. That means then I'm going to be removing 20% of n divided by 2, because it's from each side is the number I'm going to be removing from each side. That must be an integer, so I'm going to round it down. And that's where the floor function comes in. To make it easier, I sort all the results. So I use the sorted function. And then the trimmed mean is the sum of all of those that are in that range, and that should give us the so-called trimmed mean. If you don't want a floor, so you really want exactly that percentage off, you could use some linear interpolation. As you can see, it looks a bit scarier then, but we have all of this, so it's a matter of just filling out the formula, and that should be there in itself. So that's the trend mean. We could also take the proportion itself and use linear interpolation. Slightly different then you get this formula. And then we do actually need to round up a little bit, so we get this result. The Winsorized mean means that we replace the value with the closest one to it. So that's this formula. So it's very similar like the trend, but now we're replacing, and that's why I'm dividing by n. The last one is the decile mean. For that we need the deciles. That in itself is really a video by itself, so check out my quantiles video with Python. For that I'm going to cheat a little bit and just use the percentile function here. I'll fill out the 9 percentiles I want, which gives me the deciles, and I'll simply actually sum all of those up and divide them by 9 to actually get the decile mean. We've already done the mid-range, so I can remove this actually from the spreadsheet from the notebook, and that's it for this video. Alright, I hope this video was helpful, and thank you for watching.